Hello everyone. Today's video will be about solving linear simultaneous equations. What do I mean by linear? Linear means equations that are raised only to the first power, i.e. all the variables, usually the x's and the y's, are raised only to the first power. By simultaneous, I mean that we're going to have more than one of these equations and we're going to solve them all at the same time to find a solution that satisfies each and every single one of them. Okay, if we start with y is equal to 2x plus 1, and also 2y is equal to minus 2x plus 4. If we look at each of these equations individually, we should be able to see that we cannot generate a solution for both x and y, because we can only write one variable in terms of the other. If we look at this graphically, what do we get? Well, we start with our axes, x and y. We graph the first equation. It crosses at plus 1, a gradient of 2. Looks something like that. Looking at the second equation, if we graph it, we get it crosses at plus 2 with a gradient that's half as steep of this, but in the opposite direction. So it looks something like that. So we're looking for the coordinates of this point graphically when we solve these two equations simultaneously. Okay, we're going to do two methods to solve these today. Method 1 will be substitution. Now, substitution does what it says on the tin, really. We're going to substitute one of these equations into the other one to generate an equation that is in terms of one variable only. Because if it is in terms of one variable only, we can solve it. Conveniently, if you notice, the first equation has got y, one of the variables, in terms of another one of the variables. So we can conveniently substitute this y value into this equation and generate an equation that has only x values in it. If we do this, we get 2 times by y, but according to this equation, y is 2x plus 1. So it's 2 times 2x plus 1, and that is equal to minus 2x plus 4. Now we multiply out. We end up with 4x plus 2 is equal to minus 2x plus 4. If we take the minus 2x over and the plus 2 over, we end up with 6x is equal to 2, and therefore x is equal to 1/3. Okay, so now we have a value for one of our variables, but we need to get both to be able to find the coordinates of this point. So what do? Well, we substitute this value that we've just found for one of our variables into one of the equations to get the other one out. Can you see that the first equation is a lot more simple than the second equation? Therefore, I'm going to substitute my x value into the first equation. But note that you could do it into the second equation, it would just mean a little bit more work for you. So substituting this into the first equation, we have y is equal to 2 times by x, but x is 1/3, so I'm going to put 1/3 here, plus 1. So therefore y is 2 times a third, which is 2/3, plus 1. Well, 1 in thirds, so that we can conveniently add these, is just 3/3. It's a whole part. So therefore y is 5/3. So our final solution using this method is x is equal to 1/3, and y is equal to 5/3. And these are the coordinates of the point at which both of these two lines intersect. Okay, so that was the first method. What is the second method? Well, method 2 is elimination. And again, conveniently, it does what it says on the tin. And if I write out the two equations again, we have y is equal to 2x plus 1, and 2y is equal to minus 2x plus 4. So using the elimination method, we're going to use both of these equations and eliminate one of the variables. If I call this equation 1 and this equation 2, we're going to do some kind of addition or subtraction operator between these two equations, that eliminates one of the variables. Now we should be able to see that we have a plus 2x here and a minus 2x here. And if you add these together, we end up with 0. So what I'm going to do is I'm going to add equation 1 to equation 2. Now, for those of you that haven't added equations together before, what we would do is we do the left-hand side, LHS, of equation 1, and add that to the left-hand side LHS of equation 2, and make that equal to the right-hand side of equation 1 plus the right-hand side of equation 2. So if we do that now, the left-hand side of equation 1 is just y. We add that to the left-hand side of equation 2, which is 2y. And that's equal to the right-hand side of equation 1, which is 2x plus 1, plus the right-hand side of equation 2, which is minus 2x plus 4. Now if you look on the right-hand side of the equation, we've got a plus 2x here and a minus 2x here. And these would eliminate each other. That's why we did this operator. So we add the left-hand side, group the terms if you like. We have 3y is equal to 1 plus 4, because these are both gone. And that's equal to 5. And if we divide the 3 across, we end up with y is 5 over 3. Okay, so just like last time, we've got one of the variables, and we're going to substitute this value into our equations to get the other one out. And again, we can see that the first equation at the top of the screen here is more simple than the second one. So I'm going to substitute this value into the first equation. So we have y is equal to 2x plus 1, but y is 5 over 3. So 5 over 3 is equal to 2x plus 1. So I take the 1 across, we get 5 over 3, subtract 1, but 1 is 3 over 3, and that's equal to 2x. And so we end up with 5 over 3 subtract 3 over 3, which is 2 over 3, is equal to 2x. And if I cancel the 2's, we end up with 1/3 is equal to 1x, i.e. x is equal to 1/3. So if I write the solution out for this, we have x is equal to 1/3 and y is equal to 5 over 3. Note that we will get the same answer regardless of which method we use, and it's down to personal preference or whichever one is easier for the given equation. Okay, thank you for watching. I'll see you next time.